Cool. All right, we waited a few minutes for people to trickle in. This is the show. Welcome. I'm Jason Harley. I work here in Toronto. I currently work at WorkMarket on the SRE team. Previously, I worked at HashiCorp. I've sort of bumped around jobs, some would argue maybe too quickly, here in Toronto for the last 15 years or so. And I am going to attempt today, and we're all going to go through this together. So remember, empathy is a core part of the DevOps culture. Jokes are landing already. It's always good. We're going to go through Terraform. So this is me. You can find me on Twitter at Redmind. You can find me on LinkedIn. You can find me on GitHub. You can find me at the conference. So show of hands, who in the room uses Terraform? Interesting. I assume you're all here to try and prove me wrong. Who in the room has tried to use Terraform and got so frustrated they stopped? Safe space. One of you is lying, at least. I was that person at one point. And how many people are here because they genuinely want to see what the hell this thing is that's on Hacker News like every week? Yeah, all right, cool. So, by way of introductions, Terraform is an open source tool that is made by HashiCorp. It was released, I guess, in July 2014. So that was Terraform 001. For those wondering, we're at 0.12.0 right now. Still no version 1. I apologize, people who work in banks. I understand that can be difficult sometimes. Thank you for laughing. So Terraform was built to make provisioning infrastructure declarable and flexible. HashiCorp builds a suite of tools. Vagrant is probably the one that really was very popular a few years back. All of the tools are sort of based on this deep Unix philosophy of focusing on doing one thing well, right? Standard inputs, standard outputs, you have one job. This is what Bill Joy and co. were all about back when they built Unix in the 70s. And it's something that HashiCorp sort of carries through in the ethos and the design of their tools. So one of the things that I think HashiCorp does very, very well, and again, I no longer work for them, and I'm still talking about this stuff, is that they focus on workflows. Right? Workflows are what I think make or breaks tools for people who actually use them every day, right? A tool that you don't like to use, like I apologize to the blended perspective people, but like Jira can be a bit cumbersome, right? People can over-workflow that thing, and it feels like you're fighting against the tool to do your job. I think that if we're talking about provisioning infrastructure, the last thing you want is more friction, right? Like, computers are frustrating, terrible things sometimes. They're amazing and beautiful things. I love computers. I also hate computers, right? So what's sort of fascinating about Terraform since 2014, and most of this has happened in the last 24 months, is that there's this wild sort of ecosystem of providers, we call them, and we're going to talk about that in a minute, that have come up that allow us to actually build infrastructure the way that we talk about it at work anyway, right? A bunch of people may have come to this room being like, yeah, I use CloudFormation. Let's go see what this guy's on about. Or cool, like I'm on Azure, ARM's fine. And you're not wrong. Like, those are fine tools. They do a pretty good job. Where I'm going to bet you start to run into a problem, though, is that when, say, all of a sudden you want to link some Datadog stuff into the way you're managing your code. Or you want to, say, take advantage of the pretty amazing service offered by people like Cloudflare. Tying your Cloudflare config into your ARM or your CloudFormation template, well possible, feels like you just switched jobs. Even more so, how many people work at a company that's all on one cloud platform today? Just Amazon, just Azure? Right. Cool. How many people work at companies that sometimes buy other companies? Cool. What are the odds that that other company uses your cloud platform? Do you think that's going to be on the negotiating table, that they need to move? It's not happening. Terraform is a tool that will work with all of them, right? And I can actually build infrastructure that is reflective of my business instead of limited to what the cloud provider hopes that I'll pay them for. We're going to be using Amazon today because I'm most comfortable with it. Sorry, not sorry. But one more point of interest in this world, and for those who tried Terraform and maybe got frustrated with it, though I know none of you put up your hands, Terraform does not use YAML or JSON. I find these tools frustrating often. JSON is a line protocol written for computers. Humans can read it, kind of. And YAML is sometimes readable by human beings. There's that joke of the screenshot with the guy who's got the ruler on his monitor to like line all the things up. Yeah, frustrating, right? The co-founder of HashiCorp famously tweeted that as long as he is at HashiCorp, none of the tools will support YAML natively. Perhaps sounding like a bit of hubris, though it's not really, HashiCorp made their own markup language specifically focused on readability by humans. What a novel idea. To get around some of the complexities with JSON. For example, how do you put comments in the middle of your JSON? You don't. Some smart people in the room are maybe like, I use JSON-C. That's great. Nothing else uses that. So you do that thing where you do like underscore comment, and that's your comment field in that section of the document. People are nodding. You have done this. It doesn't work, right? Like, it's a frustrating tool when all you're trying to do is mark up some infrastructure. So we're going to do a little terminology crash course so that we can actually have a conversation about this stuff. I've already used the word provider. So a provider is core to how we sort of wrap or interact with another thing in Terraform. We are very largely wrapping third-party APIs. Terraform can't do anything that the thing you're interacting with can't do, right? We can't make EC2 instances magically span regions. Like, that would be amazing, I think. Like, we could just have one computer that runs our whole website in a global mesh. So we have providers. Providers give us resources and data sources. Resources are the things that we want to create. For example, we're going to start out today with the AWS instance resource from the AWS provider. So we're going to make an EC2 machine as a starting point. We'll set up the scenario in a minute. Data sources are a way that we can sort of interrogate the existing state of a thing or look at something that may already exist in a read-only fashion. And it's a way that at runtime, and we'll talk a little bit more about runtime, we can interpolate and bring rich information about our environment into what we're trying to create. So for example, we're going to start out by looking up an AMI ID. So if people are familiar with Amazon, you can't make a machine without a machine ID. So we're going to get one of those via a data source. We can make reusable sort of blocks of infrastructure via something that are called modules. We're briefly going to touch on them today. That's a very deep dive. It's also a very philosophically loaded deep dive. Perhaps most importantly, Terraform has state. And it's sort of at the heart of the declarative nature of the tool, because the ability to manage the life cycle of a thing means that you need to know what's there and what it should be doing, right? This is very different from other tools like, say, CloudFormation or ARM, or for people who have tried in vain to make Ansible do provisioning for them for long-lived resources. State is one of the most important and powerful pieces of Terraform because it tells us what's there and how it's related to the other parts. There are also variables in Terraform because it's sort of programming-y. We'll talk a little bit about how it's not a programming language. It's a DSL that allows you to mark up infrastructure, but it's not coding. And generally speaking, people who have a hard time with it are trying to turn it into a programming language. Cool. So now we get some terminology out of the way. We're going quick today, by the way. At the heart of the Terraform workflow is this idea of writing some code and doing what's called a plan. And a plan is sort of a speculative dry run that based on that state, so whether we're starting from nothing or something that's already been there, Terraform is actually going to figure out related dependencies, figure out what things it needs to hydrate, figure out if you've made any mistakes, and tell you what it intends to do. The plan's a super important part of the workflow because on longer-lived infrastructure, you find out what your coworkers have been doing in the AWS console on you as they change things out from underneath. Or maybe you find out that you've had some drift in your infrastructure or that a new feature isn't supported. The plan is sort of key to making sure that you have a clear idea of what you're about to ask this tool to do for you. Because, let's be honest, anyone who's been doing automation for any period of time knows that it's really easy to make mistakes really fast at scale, right? Like, that's the terrifying part of automation. And at HashiCorp, the other CTO, Armin, likes to talk about how we have to be mindful about building foot guns, which is to say a thing that makes it really easy to shoot yourself in the foot. So I'm not going to tell you that Terraform is or is not a foot gun. I'm going to tell you that, like with any tool of its kind, you need to be conscious about what you're asking it to do and about the time that you're asking it to make that change. After we do plans, we do applies. And applies are like the Jean-Luc Picard moment. I'm on Star Trek jokes today, apparently, where we make it so. So we've looked at our plan. We see what Terraform wants to do for us. We feel comfortable about it. We now do the apply, and it goes out and actually makes all those API calls and makes that infrastructure. So here's the scenario, and this is what we're going to spend the rest of our time working through. You are on a brand new project team that's just been told you have a greenfield initiative to deploy a tiny new application to AWS. You've been reading Hacker News like a diligent person at your lunch hour, and only on your lunch hour. And you decided that this infrastructure as code thing is maybe catching on, and the Terraform kind of makes sense too. Very specifically over something like CloudFormation, because after some drawing with your peers, you've decided that this is the end state, right? So for those maybe not as familiar with Amazon, what we've got here is sort of a pretty classic deployment of a basic application. Yes, this is basic. And this is where these tools get very daunting, right? We've got a deployment here inside a managed VPC on US East 2. It's spread across 3 availability zones. We have an Amazon ALB load balancer in the front. That's the HTTP second-generation load balancer. A pool of 3 servers behind that load balancer. We've got a bastion available to come in and do some management. Maybe we're an Ansible shop. Maybe we just don't like the idea of not having a way to get inside the kingdom when we're at home. We've also got an RDS database. It's MySQL. Actually, it's PostgreSQL. In what's called a DB subnet group, which again is some more Amazon terminology. Perhaps most importantly, and why Terraform is really shining here, is that our security department has just told us that we're all in on this Cloudflare thing. Their DDoS protection and ability to do sort of live proxying and intelligent response to threats is something that they really want to get into, and they feel that for this particular project, that's crucial. So we threw CloudFormation out because we didn't want to write custom resources that dealt with lambdas and SNSs and made API calls that we had to get someone else on another team to write, which is how you do that with CloudFormation. So this is where we're going. And if any of you just said, yeah, that's cool, it's actually pretty simple to draw some of these pictures on a whiteboard, but to not have a great amount of experience with a tool and to go back to your desk and to open up your favorite text editor, anybody who tells you that isn't a daunting experience starting with a new tool is lying to you or trying to get you to buy something. Okay, that's hard, right? And sometimes, I know this picture already showed up today, it feels an awful lot like this when people give these presentations, right? So we're going to put an EC2 instance in the thing, and then I run another command, and we've got a fucking owl. So hopefully the demo gods will be kind, because we're doing this live. And we're going to step through this, because getting all the way there is a bit daunting. I have pre-written the code. I was actually going to write it, and then I thought we would all just have a really terrible time, because I swear a lot when things don't go right, and people would be trying to help me, and I'd be telling them to shut up. It'd be really bad. So we're going to start with this. This is pretty simple, right? We've got a machine. Maybe we've got V1 of our app. It's like simple sort of responsing. And we know that we're going to put the app and the database, this is early stages, on the same EC2 instance, and we know we need 3 ports open. We need 22 because we want to SSH in and do some stuff. That or we're all little sysadmins who call themselves DevOps engineers for reasons no one is sure about yet, and we just like to SSH into machines from time to time. We also need to open 80 and 443 for the usual web reasons, right? Standard HTTP ports. So let's get into this. All right, so we're calling this Milestone 1. This is Visual Studio Code for people who aren't familiar with it. And this is HCL. This is HCL 2. We're going to be using the new Terraform today. Since we were talking about Greenfield, I thought we'd pick the new versions of the tools. For those of you who've been reading on Hacker News diligently about the delayed release of Terraform 0.12, it's here. And we're going to immediately start off with a data provider. So this is sort of the canonical Hello World Terraform example that I beefed up a little bit. And what we're doing here is that we're using one of these data sources. It's the AWS AMI data source, which, as I already sort of alluded to, looks up AMI IDs. For those unfamiliar with Amazon, you need a machine ID before you can make a machine. So what I'm doing here is I'm picking up the latest LTS version of Ubuntu, 18.04, and I want the modern hypervisor thing. We can talk about the history of Amazon's EC2 hypervisors later if you want. And I'm doing a filter to make sure it's owned by the Canonical. Canonical is the enterprise behind the Ubuntu project. Cool. So I know now that I've got the most recent ID, in my hand. All this code is posted, by the way, and you'll be able to go through it and step through it in this order if you choose. There's diagrams through all the steps, and the slides are available as well. I'll share and tweet the link after. So let's just try and be present and do this. Next up, I want that instance, right? You remember our picture. We've got that instance sitting there, sort of floating nebulously. I am going to pass it that AMI ID. And right now, we've just done sort of interpolation. We're taking a value returned by that data source, and we're saying, hey, EC2 instance, I want you to be built with this machine ID. And we know that one's going to be the latest at the time that we create it. Awesome. I'm picking an instance type. And throughout all this code, I tried to use the stuff that was available as the free tier on Amazon, so you could sign up for an account and it wouldn't cost you anything. So T2 smalls are super free. They're also super useless. Please don't run any workloads on them. I'm setting a key name. The key happens to already exist so that I can SSH into it. I'm setting up a security group, and we'll take a look at that group in a second. And I'm putting some tags on it. At the end, I'm also passing in some user data. And this is the way I'm telling the machine to personalize itself. So I am doing some sort of very Debian-specific stuff. I'm then installing SSL cert, which installs default certificates, Nginx, and Postgres 10 on the machine. Cool. I'm then enabling SSL. That's really how automation gets done in the world. And I am writing my super sweet web app, which literally reads, hello, I am hostname, and I connect to PostgreSQL on localhost. I'm not much of a Django developer, so I didn't do that for the talk. I'm then turning on the web server and the database server. Pretty good. So over here in this other file, just to sort of keep my own focus, I built that security group we just talked about. So it's got a name, app.sg. Pretty good. I allow default egress outbound to everywhere. We're not a bank yet. And then I drop in 3 rules for those 3 ports we just saw, right? I open 22 to the world, I open 80 to the world, and I open 443 to the world. Boss. Not too bad. Feeling pretty good about that. So that code builds this. Should we make it real? Like, this guy's talking a lot. Let's see this go. So the first thing we do when we start any sort of new Terraform project is we need to run this thing called a init. And init actually goes out and downloads all the providers that you're using. Point of fact, and we'll see this later because I'll forget to type it, when you add a new provider into something you're already using, you need to rerun init, and it will go fetch the things again for you. So for those of you who can read it, and hopefully most of you can, we've downloaded some stuff. So next in our journey, based on that very poor picture I drew, we do plans, right? So we run Terraform plan. And it says it's going to do a bunch of stuff. I'll bump that up one more for the people in the back. The most important part here is that line just above all of the hyphens. He says, see, it says 5 to add, 0 to change, 0 to destroy. So we're greenfield totally at this point, right? Like that is a nebulous little thing floating in the ether. Try explaining virtual machines to someone sometime. Whoa. It's an OS that runs other OSs. They're not listening anymore. So we're going to add some of those security group rules we just saw. There's that security group. Here's the definition of our machine. That's kind of big and fancy. Because Terraform is so stateful and you're telling it that it owns this resource, even for things that we didn't tell it specifically to set, it has default values for, and it's going to populate and track those. And for drift detection, this is super, super helpful. Because you can actually see if someone's gone in and added some more tags to your instance. And you can be like, yo, Tony, why did you log into the thing and add that tag? I don't understand. You know, we're doing this infrastructure as code thing now. We do that. We do that in GitHub. Cool. So let's make it real. So we do an apply. And the apply actually does another plan. That one was super quick. I had credentials cached. And apply is going to ask you if you really want this to happen. What it's actually telling you to do is to read that line where it says 5 to add, 0 to change, 0 to destroy. Because if I had just come in here and it was saying something like 14 to change, 500 to destroy, something has probably gone terribly wrong, and I shouldn't type yes. It will do exactly what you let it do, right? So be mindful. Cool. So that infrastructure is going to get fired up. for those sitting there wondering, well, how does it decide where to start first? That's kind of the beauty of this tool. It understands the relationships between things. And part of that logic is encoded in it. So it understands that in order to create a virtual machine, it first had to create the security group. Because the EC2 API, you send it a security group to attach to the thing. And if we don't have one yet, it's sort of inefficient to send no security groups and then make another call to modify the security groups. It's not really worth it. So in that plan, part of what it's doing is actually sorting out all those relationships for you. You can see that we're done. Sweet. And this is sort of the moment of truth, where we wait to make sure that it's real. So first, while we're waiting, let's go into the Amazon console just to prove to you that I'm not totally faking this out. This is US East 2. And we just launched that machine. It's called app. It's a T2 small. It's probably even got those tags on it that we talked about. Yep, environment and test. Pretty good. For those wondering why it's taking so long, user data is actually run after the machine comes up, and the hypervisor checks out that it's all OK. So there's this brief pause. And for people who are looking to getting into cloud provisioning, welcome to the sweet surrender of not being able to control the determinate nature of when any of this stuff happens. Cool. So for the very anticlimactic feature there, my final curl just worked. And you can see it says, hello, I am IP 172.3.1.5.133, and I connect to PostgreSQL on localhost. So we wrote that. We did it. Flags on the moon. We can maybe use this Terraform thing. For anyone familiar with Amazon at all, if you were sitting in the back being like, why is this guy using the default VPC? You're not incorrect. That violates every best practice that they teach you at Amazon school. So this is where we're going next. And this is where we're making the networks real. If you're looking at that and saying, Jason, that is going to be a lot of typing based on the security groups I just saw you set up, you're not wrong. Creating a VPC on Amazon is about 15 steps. It is annoyingly complicated. It's one thing GCP did really, really well. I believe it's one step. So what we're going to do here is we're actually going to phone in some help from a friend. And this is where we start to talk about modules. So Terraform has this thing called the Terraform Module Registry. Modules have been in Terraform, I think, since version 0.4. The Terraform Module Registry was written for two reasons. One, to allow people to share things that they've written. Community and collaboration is sort of a way of an open source project getting some traction. Also, it's going back to that leaving the whiteboard where you drew the picture and looking at that text editor and wondering where to start. This is an amazing resource of places to go to actually see how people have solved building complex things with Terraform. There is examples of like Cassandra clusters that you can go in and look at how someone solved that stuff. I'm going to warn you, please do not pick them up directly and run them in your business with the production workloads. Make sure you understand what's happening before you do that. This is analogous to Ansible Galaxy or Supermarket with Chef, or I forget what the Puppet one's called. Cool. So we're actually going to use one of these, and we're going to use this super well-done VPC module from the public module registry. And those 15 steps are actually going to turn into not that much code for us. So at stage 2 here, I'm diffing the two milestones. That's why it's green and pretty. Hopefully it's pretty. So what we're doing here is instantiating a module. And this module is going to help us out, and it's actually going to go, and we're just going to tell it a few inputs, things we care about. Our network things. Is there any network people in the room? No? The thing about clouds is they made people hate networks even more. No one wants a network. People just want the thing on the network, right? So this is sort of necessary work. So what we're doing here is we're standing up our 3 VPCs. There's a function involved there, though, and you can see that we're actually just picking 3 VPCs, 3 AZs at random from the ones available in this region. We're passing in 3 public subnet ranges and 3 privates, and we're doing this true stuff. Basically, we're saying we want our VPC to be able to talk to the internet with those. On AWS with VPC, you have to have a NAT gateway to facilitate that. We tag it because tagging is good practice. 2 more key things. We now have to say our security group is scoped to that VPC, right? Security groups in Amazon are a construct that are VPC namespaced, for lack of a better term. And if we come over here to our machine, we're now actually doing the same things with the subnet ID. So we're picking the first or the 0th element from our subnets list. Still the public subnet. Remember our picture. We just kind of overlaid a new network topology here, right? So still a public subnet, still our app, still our 3 ports. Anybody want to take a guess on what the plan's going to look like? No? No takers. We got add 1, change 1, delete 1 in the front. More people should suggest things, which is to say he's not right. I appreciate the participation. So 33 to add, 0 to change, 5 to destroy. So we're talking about destroying things now. This is maybe a little bit scary. Cool. So 33 to add, that's that VPC module helping us out, right? We just told it a few things we wanted, some networks, some stuff like that, and it's actually doing all that work. It's laying out the subnets, it's laying out the NAT gateways, the internet gateways, all of the jazz. That is a very good module. I would actually use that in production myself. Also, those changes, and we'll scroll up to see them. So we see that these things have to be replaced, right? And that's because of how things are scoped. So this is an Amazon API limitation. Amazon says that you can't actually just move a security group into a new VPC. They are scoped to that namespace, and they are immutable in that regard into where they belong. So we're actually going to delete the old ones and make new ones in our new VPC. That seems fine. Like, we know our desired end state at this point. We're going to do that. Unfortunately, though, we got to do the same thing for our instance, because the same rules apply. I'm moving subnets, and I can't just pick up a virtual machine in EC2 and move it to a new subnet. I can snapshot it and create a new thing, for those of you who are like, yes, but. But we're kind of embracing this immutable thing, so let's give this a whirl, right? I'm going to auto-approve it in the interest of time. Auto-approve is basically saying don't prompt for yes. So we just saw that plan. I'm the only one in my account. I'm pretty comfortable with this change. So this is a lot more work all of a sudden. Yeah, question?
Are things like disks also, you have to destroy them and recreate them?
So EBS volumes in particular, it will do its best to move them around. EBS volumes are scoped to availability zones, if I remember correctly. So if something ends up moving there, you might see that it wants to change them. But largely it depends. I'm not using any additional storage on this one. So just the root volume, it's a blowaway machine at this point anyway because I've codified that config. I might have had Zeta in that database, though. It's gone now. Because it's winding it out. All right, so while that's applying, let's go look at what's sort of happening in this Amazon dashboard. And over here, you can see my original one's already gone. It shot it right away, the end. The new one's still spinning up. Some stuff's happening there. Getting new networking sorted out. This NAT gateway thing is it's currently making the egress endpoint to move out to the internet. This is just like standard Amazon networking. Welcome to the wild world of AWS. Yes? Great question. The question was, are NAT gateways required, or can it just use any IP? It depends on your IP schema. That machine was not configured to have a public IP attached to it. It is an option. You can turn that on, at which point it would be able to speak directly to the internet. This is an attempt to do a little bit of best practice-y, so I have private IPs on all my machines. But great question. Cool. NAT gateways take a few minutes to make. So in the interest of time, because we're running up on it here a little bit, we'll come back and prove that I didn't make this up. But let's talk about milestone 3 for a minute. So this is the scaling up, scaling out, I think I called it. I thought I was funny 3 hours ago when I made that little joke. So this is sort of everything but Cloudflare, right? Cloudflare is our pièce de résistance to finish this thing off. So this is a lot more stuff, right? What we're going to do to expose this is we're going to take advantage of Terraform's basic form of iteration. So we're going to make those 3 machines using the count operator. So we'll get a little bit of not quite so much copy-pasty code. In order to enable this networking, though, we're going to have to do a little bit more work. How many people are familiar with load balancers on Amazon? Cool. So we're going to have to make a target group and attach all of our instances to it, right? That's how this stuff works. And there's more security groups involved there, right? Because our load balancer needs to be able to talk to our stuff too. Before we jump into that, let's see if our plan's done. And it is. So at this point, we're scoped in our VPC. New instance, for those paying attention, that's a different IP because it's a different machine. New instance is right there. Our message is good. So let's take a look at Milestone 3 now that we're iteratively building this up. All right, so let's look at our instance. This is kind of different. Green is new, red is what we deleted. First thing is we got this count operator. Cool. So by default, there's actually an invisible count 1 on most things. You can set count 0 on things and they want to be deleted. What we're saying now, though, is that we want 3 of these. Still with that AMI we were looking up before, still T2 smalls. Now we get into some of the complexities of count. And this starts to look a little bit funny, maybe. The subnet ID, because I want to kind of spread these out, right? You remember my picture. What I'm going to do is I'm going to look up. So the element operator is like index of, like give me the thing at this place in. I'm going to look up in all of my private subnets, and I want the subnet that matches my count. So the 0th time through my count loop, I want the first member of that private subnet group. The second time, I want you get the idea, right? Cool. I'm also now attaching one more security group because I want to talk to that database, right? I've got that external database now. I'm 3 machines now. I'm scaling out. I'm web scale. I use Postgres, not Mongo. I apologize, but one person laughed. That's good. Finally, and this one's kind of neat, the name tag is changing. And what I'm doing here to sort of help me and my coworkers out, maybe, is I'm setting the name of the machine in its tag to be app%2d. So for people who have done printf recently, that means I want count plus 1, so non-zero starting, and I want you to pad it with 2. So I'm going to get machines named app01, app02, and app03 appropriately through that loop. This lifecycle block we'll talk about later. In the name of transparency, since we moved Postgres out, I deleted it from my user data to start it up. I'm now making a Bastion host. This is that SSH box that was over on the left-hand side of the diagram. This one's also a T2 small, also an Ubuntu machine. Got its own security group, though, because we're just allowing 22 into it. And I'm placing it in a public subnet, because I want it to be on the internet directly, right? Finally, here's a new resource, 2 new resources for us, actually. AWS DB instance is how we make things with RDS in Terraform. Cool. So I'm making a very tiny managed Postgres database. I am placing it in a database subnet group that was created by our friend, the VPC module, another thing we didn't have to learn too much about. Thumbs up. And perhaps most interestingly, I'm generating the initial RDS password using the random UUID provider. So this is something we can get back, immediately log in, and change, right? No one leaves that password around. No. Cool. There's a bunch of network changes to jump from 2 to 3. All this code is available. The most interesting one for us, though, is the way we're standing up these load balancers, or this load balancer, pardon me. We make a new load balancer here, and we're going to scope it to that VPC, right? Everything we're doing is in that VPC. We have to be very explicit about that. Sorry, that's a security group. The load balancer is right here. It is a public load balancer, and I'm making it across all my security groups. So I'm taking advantage of all those data centers. I then got some rules. I allow 80 and 443. That's great. I then make a target group. And target group is how you tell a load balancer what to talk to. So despite the fact that I have 80 and 443 open on the front of my load balancer, I'm only going to open 443 to my machines. I've kind of bought in this idea of that, like, you know, maybe we should encrypt traffic on our networks. Seems like it could catch on. So on the port 80 listener for the load balancer, it's going to take care of the redirects itself. So this is one thing I don't have to worry about. ALB could do this as of a year ago. I learned on Saturday. And for HTTPS, what we're going to do is actually loop again through all of those machines we created. And this is the magic that's going to do that for us. So we're using count again. What we're saying now is however many instances you created, I could have just set that to 3, but now I would have to make changes in 2 places, right? This way I could change count to 5, and we could scale up, super web scale, 5 instances. I'm going to loop through all of them, and I'm going to attach them to that target group. And I'm going to send that traffic to port 443. Shall we see if it's real? Let's do it. So I do a plan, and it fails right away. Because the random provider is a new provider. We haven't used it before. And Terraform's only going to pull down what you ask it to. Thankfully, with Terraform 12, it's actually very good about telling you what you didn't do yet. So I'm going to do an init. It's downloaded that provider. Awesome. Now we're doing a plan again. This really is what it's like working with Terraform. You make some code changes, you run plans, you look at it if it looks like you want. If it is, you run apply. So at this point, we're adding 30 new things, and we're destroying 4 of them. The destroy 4 is the part you always want to check out. You should care about what's being added. Destroys are usually up at the top. So what's happening here, because we plucked out some of those security group rules, we don't want 80 available between our load balancer and our machines anymore. The machines used to have port 80 open. We're closing that up, so that's being yanked out. We're also now removing some of the rules directly from the Bastion. Yep. We're allowing traffic from the load balancer to our instance. And way up here, we can see that it's actually making more machines. Most importantly, it's actually going to delete our first one. Oh, no. Yep, it is. Yeah, because it's actually being pushed into a different subnet now. We've moved out of that public tier down into the private tier, so that machine, again, needs to be destroyed. So let's do this. So again, this is Terraform going through and taking us to this state. And this is, for those who are new to Amazon or playing around with it, this is a pretty standard little setup for an application, right? We have a fairly secure perimeter. We have a way to get in to do management. We have a pool of machines. And we have a database that Amazon is managing for us. This is pretty real. One of my pet peeves with TechTalk sometimes is that someone introduces you to something, and it's so fake that you feel like you didn't learn anything. So I wanted this to be as real as possible, and I apologize that this might feel very dense and very quick, which is why I'm sharing all the code so that you can try it yourself at home. Free Amazon account if you want. I don't work for Amazon and never have, but like, you can sign up for a free account. So this is what's going on. It just spun up our Bastion. It's building our load balancer right now. And over here in the console, we can sort of see in the wake of Terraform what's going on. So the Bastion host is being created. It hasn't yet pruned our original app server. And over on the side, because things are actually happening in parallel here, we have a database? Yeah. So it's already made our app test database for us, right? So Terraform is smart enough because it understands all those dependencies that it will try and parallelize as much work as it possibly can. Unfortunately, that means it will parallelize deleting things as well, which is why you should make sure when it says destroy that you know exactly what it's going to do for you. Load balancers take a little bit to come up. It hadn't made the other ones yet. The question was, on the EC2 console, why did it only show one app instance? It hadn't yet started making the other ones. So it's clearly waiting on something to happen before that. My guess is in its plan, it wants to make the load balancer and the target group, then make the instances, and then attach them to the target group.
Does it do it all in parallel?
Question is, does it do it all in parallel? It does as much as it feels it can safely do in parallel, though the default limit is 10 actions at once. You can change it with an environment variable in your plan. Yeah, in your apply, pardon me. Yeah, max parallel is the environment variable. Any other questions while we wait for this? In the back, red shirt. They're repeating it out for folks. Why only 10 actions at once is the default in the tool? Amazon and most APIs have intense throttles on them to prevent people from abusing their perimeters and their ingresses. So Terraform tried to pick a respectful default that wouldn't be too outrageous and also wouldn't turn your machine into a bottleneck, right? It's like when you're doing benchmarking and you're actually benchmarking your workstation, not the stuff. So 10 was selected as sort of that default starting place so that you didn't hit API throttle limits, basically. Sure. The question is, if a change was made manually to an instance after it was created with Terraform, what would it put it on sync, and what would it look like? So first of all, and I apologize, this is a little bit of a flabby answer. It depends on the change. The password on the instance, it wouldn't care. If you did something like attach additional disks, or change the tags, or change the type of the instance, absolutely. Terraform would actually, in a plan, show you that it wants to pull that back to what it understands as the source of truth. If you're talking about someone logging into the machine, in this case, and installing a bunch of software and all that jazz, Terraform doesn't have purview into that. Cool. Question was, is there a situation that I can sort of think of if someone went in and, say, swapped 80 and 443 and made a bunch of security group changes, would Terraform not be able to sort of remediate that state? I haven't yet seen it, to be perfectly honest. Like, if we're talking about network groups in particular, largely because if it thinks that things have gone really south, it will just delete the security group and make a new one. Sometimes, though, and that's why you need to watch what it's telling you it wants to do, if you've done things like move that instance to a new subnet, it might decide that what it needs to do is delete it, right? And as with all of these tools, automation is powerful and wonderful, but you need to understand what you're asking the thing to do for you, and sometimes that can be hard lessons. Absolutely, and we're going to finish the talk with it. Is there a way to destroy everything you've deleted? There totally is, and it's how we're going to wrap this up. So we're just about done. Question in the front, blue. Yeah. Yeah. Great question. Does it try and force you towards best practices? Not really. It will let you do freeform things because it's really just wrapping the API. So like we started out, for example, I created that instance in the default VPC, which is basically against everything Amazon tells you should do ever. I use the default VPC for building AMIs, and that's about it. OK, we made it through that. Awesome. So again, to prove this is real, I'm going to SSH into my Bastion host. That seems pretty good. All right. So we set up a host. I can SSH into it. So can anyone else on the public internet who has my key, apparently. I also outputted one more thing. I outputted the load balancer DNS name. Sorry, I'll bump that up. So I got this wild DNS name, which is not any way I really want to run my business, maybe. But if I open this up, cool. So I got a load balancer. And this time we hit 183. That time we hit 175. That time we hit 1017. So we got 3 machines. We stood this up. Feel pretty good about it. We got one step left, though, right? That last thing, the security department, they want that Cloudflare stuff, right? So our final step is to protect that load balancer with the Cloudflare CDN. I talked at the beginning about this sort of fascinating sort of ecosystem or halo effect that's come out around Terraform. This is actually a really hard thing to do in most of those other tools. We're going to do it in about 12 lines. And this is why I think you should give a shit about this tech. Because it actually makes your life easier at work, and it allows you to build infrastructure that works the way your company wants it to work, and not the way your cloud provider, who you absolutely have an important partnership with, wishes that you would just consume, right? Real companies build infrastructure with solutions from different places. That is fact. That is going to be that way forever. I would challenge you to use tools that allow you to build infrastructure the way that you need to build them to solve your business's problems. And I think this is one of the only ones available on the market, and it's free, that can do it for you. So let's take a look at it. Okay, Milestone 4. We're just about there. Cloudflare.tf. So the first thing, this is new. I made a variable resource. This one's actually going to read the variable out of my environment. I bought I call myself Redmind because I have a lot of red hair. It was cool when I was 18. That was a while ago. I'm going to pull this Cloudflare zone variable out of my environment. I'm then going to set up a Cloudflare record. How many people are familiar with Cloudflare? I've been talking about it very casually. Cloudflare is a DNS solution that can offer you DDoS protection and caching. Worldwide network, they do some really cool stuff. Their research division is actually amazing. If you want to read some stuff about like how tiny settings can change the world, very smart people doing really cool tech. What we're doing here, instead of using like our standard DNS, is that we're going to use Cloudflare DNS, and we set this proxied equal true thing. And that's Cloudflare parlance for I want the DDoS and I want the caching. It's that easy. I just turn it on like that. Where this gets really cool, and this is maybe a little bit subtle, is that I am telling Cloudflare that I want a CNAME record to point to whatever the value is of my Amazon load balancer. And it's just going to figure that out for me. I'm not going to log into the Cloudflare UI. I could to show you it was real, but I'm not going to. This is where this stuff gets cool. I'm stitching together at plan time, or at apply time. I call it runtime. I'm stitching together infrastructure the way I built it, right? So even if I did another, like my load balancer got deleted for some reason, maybe it needed to recreate it, maybe I switched the type, Terraform's going to see that that changed, and it's just going to update the Cloudflare record, and we're like, it's no big deal, right? You don't need to file another ticket. You don't need to. How many people have done change control with their coworkers via email, and you're like 45 deep, and you're including screenshots where you're circling the bits of the part that you changed, and they're like, no, it's the wrong machine. I needed app 27. Why did you detach the disk from app 46? That's how change control worked before stuff like this, right? Like this is a new world, and we can stitch this jazz together. All right, so final step. You've all been very patient. Milestone 4. What's the first thing we should do in Milestone 4? Init, because we got a new provider. So we just reached out, we downloaded that Cloudflare provider. Now we can do a plan and see what needs to happen. This is actually the nicest plan. This one isn't anxiety-inducing at all. So what it does is checking the state of everything. Again, Terraform controls it and is going to tell us what it needs to do. This is like a pleasant plan, right? 1 to add, 2 to destroy. That's interesting. So in this step as well, we're actually going to rip out the 80 listener on our load balancer because we want to get rid of that clear text port. We're going to let Cloudflare deal with all our ingress traffic, and our border is now 443 only. 1 less port to tell security about. That must be like 50% off Qualys scans. Like, that's pretty good. Security people laugh. Thank you. Cool. So we delete the 80, and we set up this record. Let's cook it. So again, our load balancer's staying there. Our machines are staying there. All we're doing is ripping an open port out and putting that DDoS protection in at the edge. This is the best I've ever typed in front of a group full of people. I changed our outputs too. And now I got this public hostname thing. So we set up our Cloudflare record at app.redmine.xyz. So for the great finale, and I'm going to need everyone to clap here, so I'm a fragile person. I'm going to open this up, and it should redirect from 80 to 443. No scary Chrome certificate warning. It should be good. And it's still just going to have that ugly text string, though. OK, we ready? We're doing this. We're in this together. Remember empathy if it doesn't work. Oh, man. OK. So we just mixed providers. You can do this with Datadog. You can do it with SignalFX. You can tie Amazon and Azure together. Whatever you want to do, you got a canvas for it now. And the coolest part is you don't need to learn a new tool every time. You just need to learn some new resources. The documentation is quite good. And it's pretty easy to experiment, right? Like I hope this felt like a reasonable pace and that we actually maybe accomplished something. So let's wrap this up. Where do you go from here? I would encourage you to browse the documentation for the AWS provider or whatever cloud provider you happen to be. You can do this with VMware, by the way. Same workflow, plan, apply, vSphere, good to go. There's an ESXi provider as well. It doesn't work quite as good. It connects over SSH, and it's a little flaky. I need you to read up on remote state management. I didn't cover it in this talk. It is crucial if you are going to work in teams and build real infrastructure. That Terraform state I was talking about only exists on my laptop right now. HashiCorp just actually made remote state management free. They released it with Terraform SaaS. Please don't use it for work without talking to your appropriate legal teams. I would also invite you to browse the public module registry, right? We looked at it briefly. It's where we got that VPC from. Then, I want you to try writing your own app module. I want you to try and take, and you can tell me to blow smoke if you want, I really don't care, but I challenge you to encapsulate most of what we just did in its own module. And most importantly, I want you to have fun. I love infrastructure. I love technology. And this is a tool that actually made me love it more. Clicking around in the Amazon GUI is soul-crushing and error-prone and unrepeatably awful. Actually, it's very repeatably awful. Even if you don't think Terraform's for you, I encourage you to look at an infrastructure as code tool, because this is where we're going. This is how we're going to be able to actually sanely manage the incredibly complex and convoluted things that we need to build today. Think about 5 years ago. How much simpler was tech? It's only going to get more complicated, folks. I think we're basically at time. I'm here for the rest of the time. You can contact me at any of these places. The final line on the screen is where all of this code lives. I will tweet it under the DevOps Days Toronto hashtag, so you can find it. You can follow me on Twitter if you want. I basically don't tweet, though I try sometimes. I usually typo at least once. They won't let me edit. Any questions at all? We can come up to the stage. I don't know how we're doing on time. So many questions, good Lord. At the back, I haven't spoken to you yet. The lifecycle documentation is on the Terraform docs. They're actually great. Go to terraform.io and click docs in the top panel. Lifecycle blocks are a way that you can sort of control how things come in and out. And they're very important in production environments. Yes? Yes, it only cares about the parts that you tell it about. On that note, I would encourage you, if you are moving to this tool, there's all this documentation about importing things into Terraform. Please, please, please do not start with imports. You lose all of the benefits of the tool, you have a frustrating experience, and you've delivered zero business value. Start with a simple project, and as you get more complicated, you'll just naturally find that now's the right time to import the VPC I already have, for example. Great. TerraGrunt is a tool that was created specifically to help manage dynamic provider blocks. They also have a very opinionated workflow as to how to move Terraform changes through lower environments up to production. I personally haven't used it. I haven't found a need for it. People who like it a lot. One problem I have with tools like that, and this may be me speaking as an ex-HashiCorp employee, is that you're sort of beholden to their update cycle sometimes, right? Like Terraform 0.12 just came out. I have no idea what their status is on supporting that. I'm not fear-mongering. I'm just sort of calling out where things get tricky in that regard. Great question. And thank you very much.